Chapter 2 Polynomial Session 2. Let's start. Exercise 2.1 Question 3. Give one example of each of binomial of degree 35 and monomial of degree 100. Binomial of degree 35. So m power 35 plus 62. So you can write down any example. For example, minus x to the power 35 plus 9, or you can say 98 minus 3x to the power 35. In short, the highest power must be 35. For example, if you can write down minus m power 35 plus 9, that is also fine. So you can go with the any method, or actually you can go with the any example. There is an ample of example you can write down, but in the end you need to decide that which example you need to write. Simple, right? See, monomial with the degree 100, so it is here I write down t power 100, but if you want to write down minus t to the power 100, that is also fine. If you can write down minus 35 x to the power 100, that is also fine. If you want to write down minus x to the power 100 or minus 35 m to the power 100, 35 m to the power 100, 60 t to the power 100, each and every example is fine, but in the end it is you need to decide that in which way you need to go. Now write the degree of each of the following polynomial. See, degree means what? So degree is nothing but the highest power of the given polynomial. Degree is nothing but the highest power of the given polynomial. So here what is the highest power? 3. What is the highest power? 2. So degree is 2. We just focus on the highest power, right? The highest power is 3, so degree is 3. Highest power is 2, so degree is 2. Here the highest power is 1 because t has no power. If I can write down only t, it is simply means the power is 1. So the degree is going to be the 1. So degree is 1. Here only 3 is written, right? We've already seen the theory part that if it is only constant is written, so the variable has a power nothing but the 0. So that means the degree of the constant term is nothing but the 0. So the degree is 0 or a constant term, but we need to write down the degree. So that's why the answer is this, and that is degree is 0. 5. Classify the following as a linear, quadratic and a cubic polynomial. Classify following as a linear, quadratic and a cubic polynomial. See, first here, linear means what? Degree 1 or highest power is 1. Quadratic means what? The highest power is 2. Cubic means what? The highest power is 3. The highest power is 1 or degree 1. Highest power is 2 or degree 2. Highest power is 3 or degree 3. Okay? See here, what is the highest power? 2. So it is a quadratic polynomial, right? So here, now here what is the highest power? 3. So it is a cubic polynomial, right? Here what is the highest power? 2. So it is the quadratic polynomial, right? 1 plus x, the highest power is 1. So it is going to be the linear equation. So here 1 plus x. R square, the highest power is 2. Degree is 2. So it is going to be the degree. It is going to be quadratic polynomial, r square. Here it is the cubic polynomial. The highest power is 3, so it is going to be the cubic polynomial. So it is the cubic polynomial. Okay. So this is simple. In this way you need to classify. Now, this is very much important. 0 of the polynomial. Zeros of the polynomial. In the 0 of the polynomial, there are 3 things that we need to know. First of all, find out the value of the polynomial at given point. At means after add there is a given point, right? At a given point. find the zero of a polynomial and check whether the given value are the zero. Given values are of the zero of the polynomial or not. Check whether the given values are the zeros of the polynomials or not. See here. Find out the value. It means what? See here. If this is the polynomial, this is the polynomial, and we have to find out the value of this polynomial. We have to find out the value of this polynomial at x is equals to 1. This is the example. These three are the example to understood this statement. Now we have to find out the value of this polynomial at x is equals to 1. So it is simple. We simply have to put the 1 instead of this x. Instead of this x, we have to put the 1. Right? So put here 1. Instead of x square, 1. It means 1. Instead of x, 1 and 7 as it is. So 5 ones are 5. 3 ones are 3 plus 7. 7 and 5, 12. 12 minus 3, 9. 9 is the answer. Now find out the 0 means what? See, this is the polynomial, right? See, this is the polynomial. P of x is equals to x square minus x minus 6. Okay. Now what you have to do? Compare it with the 0. Compare it with the 0. Now how to factorize? You already did in the standard 8. So how to factorize it? Say it is simple. It is minus 6. So we need to find out the two factors, and that is 3 2s are. Right. So here 3 2s are, it's 6. But we need a minus 6 is coming over here. But after that I want here minus 1. So what I do is minus 3 2s are. So it is going to be the minus 3 plus 2. Okay. So x minus 3 x plus 2. X minus 3 x plus 2. Then x minus 3 is equals to 0 and x plus 2 is equals to 0. So therefore x is equals to 3 and x is equals to minus 2. So therefore x is equals to 3 and minus 2. X is equals to 3 and minus 2 are the 0 of the given polynomial. Okay. So this is the find the 0. So these two are the 0 of this polynomial. Now how can you say that there are the 0? So check this. Here we have given the p of x, but instead of x you put the 3. So instead of x I put the 3 here in this equation. So instead of x what I have to put is 3 square minus 3 minus 6. 3 square is nothing but the 9. Minus 3 minus 6 is minus 9 is equals to 0. If you get the 0, your answer is correct. Similarly, p of minus 2. So p of minus 2 is what? So here you have to put the minus 2 square minus minus 2 minus 6. Minus 2 square is what? Now minus 2 square is what? Plus 4. Then minus into minus 2 into minus 6. Now minus into minus plus. So it is 4 plus 2 minus 6. 4 plus 2 6 minus 6 is 0. So both are the 0 of the given quadratic polynomial. Now check whether the given values of the 0. Now check whether the given values are the 0 of the polynomial or not. So verify 2 and 1 are the zeros of the polynomial x square minus 2x or not. So now let's check it. Simple. See, we have to check whether 2. So instead of x, instead of this x, you have to put the 2. So this is going to be the 2 square minus 2 into 2. 2 2s are 4. And this is 2 2s are minus 4 is equals to 0. See here? Yes. If it is 0, then we can say yes, 2 is the 0 of this polynomial. 2 is the 0 of the given polynomial. Now, what we have to check? We have to check whether minus 1 is the 0 of this polynomial or not. So instead of x, what I have to put is 1. So x square minus 2x. So instead 1 square minus 1 square minus 2 into 1 is equals to minus 1 is not equals to 0. Minus 1 is not equals to 0. So 1 is not the polynomial of the 0 of the given polynomial. So 1 is not the 0 of the given polynomial. In this way you need to do this thing, and on the basis of this three thing the next exercise is based. Okay, so find the value at means what, you need to replace simple. If it is 1 you need to replace x with the 1. If it is 2 you need to replace x with the 2. Simple. Find the 0 means what, you need to compare the given polynomial with the 0. After that factorize it, and if it is given like this 2x minus 5, so you need to factorize it. Just 5 goes on to the another side, 5 goes on to the another side, it becomes is equals to 5. 2 from the numerator goes into the denominator, so x is equals to 5 divided by 2. So this is the way we can solve. Okay, this is now let's move ahead. Exercise 2.2, find out the value. This is the first question. Find out the value of the polynomial 5x minus 4x square plus 3 at x is equals to 0, minus 1 and 2. So first x is equals to 0. So simple, instead of x, wherever you find out x in this polynomial, just put the value 0. So here x is equals to 0. So p of x is this, is the p of x. Now instead of x, what we have to write? We have to write down the 0. So this is the p of 0 is equals to 5 into 0 minus 4 into 0 square plus 3 is equals to 0 minus 0 plus 3 is equals to 3. So p of 0 is 3. Okay, so p of 0 is 3. In the same manner at x is equals to 1, so instead of x, what we need to put is minus 1 is equals to 5 into minus 1 minus 4 into minus 1 square plus 3. Now 5 into minus 1 is what? Minus 5. Minus 4 minus 1 square is 1, so 1 fours are 4 plus 3. Minus 4 minus 5 minus 9 plus 3 is equals to minus 6. So p of 0 is minus 6. Now at x is equals to 2. So p of 2 is equals to 5 into 2 minus 4 into 2 whole square plus 3 is equals to 5 2s are 10 minus 2 2s are 4, 2 2s are 4, 4 4s are 16 plus 3, right? 10 minus 16 plus 3, 10 plus 3 13, 13 minus 16 minus 3. So p of 0 is nothing but the minus 3. Okay, now let's move ahead with the another sum. The same thing, but here you have given directly that you need to find out the value of p of 0, 1 and 2. So here in the first example, see, don't be confused. We did here for the p of x. Here if it is given p of y, simply you need to replace the value of y with the 0, 1 and 2. So here, first of all, p of 0 for this polynomial. So p of y is this. Now instead of y, you need to put the 0. So this is 0, y 0 and this is 1. So the remaining thing is what? 1. Now 1, you put the, now we have to find out the value of p of 1. So p of 1 here in this, so 1 square minus 1 plus 1. Now plus 1 and minus 1. Now, minus 1 plus 1 0, and the remaining thing is what? 1. Similar 2. So 2 square minus 2 plus 1, 2 square 4 minus 2 plus 1, the answer is 3. Okay, so in the same manner you need to solve this also. How? See, p of t is given, but you have to find out the p of 0. So wherever you find t, you need to put the 0. So 2 plus 0 plus 2 into 0 square minus t cube means 0 cube is equals to 2 as it is, 0 gone, 0 gone, 0 gone, so answer is 2. Why? Because you can multiply 0 with anything, it becomes 0, and if you add 0 to anything, the answer is the number itself. So P of 0 is 2. In the same manner, if I have to write down the P of 1, then 2 plus 1 plus 2 into 1 square minus 1 cube. So 2 plus 1 plus 2 minus 1 plus 1 minus 1, answer is 4. Answer is it's 1. So answer is 4 here. This. Now instead of t you need to put the 2. So 2, here also 2, here 2 square minus 2 cube. So this is the 4, 4 2s are 8, this is also 8, this is 8 and 8 0, because 8 minus 8 it becomes 0, the remaining is 2 plus 2, 2 plus 2 is 4. Right, so in this way you need to solve the sums. Right, the last sum I am going to do it, and the last sum of this question you need to do it by yourself. This is the simple x cube. So P of 0 is equals to 0 cube is equals to 0. So 0. Now P of 1, so 1 cube is equals to 1. And P of 2, it is nothing but the 2 cube is equals to 8. So these are three the answer. And this is the self practice. Do it by yourself. If you are comfortable, directly put the value 0, 0, 0 minus 1, minus 1. 0 plus 1 plus 1, answer is minus 1. So in that manner you need to solve, or else x into x, x square, x into 1, x minus x, and this is the minus 1, or you can directly write down this is x square minus 1, this is the identity. Whatever way you are comfortable with, just do it. This is the maths, and you can do one sum in so many ways, but the thing is the math must be right. Okay, now let's go forward. Verify whether the following zeros of the polynomial indicate against them. See, this means what? Whether x is equal to minus 1 by 3 is the zero of this polynomial or not. So what we have to do is P of, instead of x, what do we have to put? We have to put the minus 1 upon 3. So minus 1 upon 3. Minus 1 upon 3 is equals to, so wherever you find out x, you need to put the minus 1 upon 3. So see, 3 into minus 1 upon 3 plus 1, 3 and 3 cut. So here what is remaining is minus 1 plus 1 is equals to 0. And if we find it is equals to 0, if it is 0, then yes, this is the 0 of the given polynomial. Right? See here, P of minus 1 is minus 1 upon 3 is 0. Since it is 0, therefore x is equals to minus 1 upon 3 is the 0 of the given polynomial. It is that simple. In the same manner, you need to do the another sums. Here it is that 5x minus pi. So you need to put 4 upon 5 instead of x. 4 upon 5 minus pi, 5 cut, answer is 4 minus pi. So it is not equals to 0. It is not equals to 0, right? Since it is not equals to 0, this is not the 0 of the given polynomial. Okay, so value of pi is 3.14. And if you cut this out, you will remain with the 0.86, and that is also not equals to 0. Okay, now x square, here we have given the two values, so we need to find out in the two. P of 1 is equals to 1 square minus 1 is equals to 0, and P of minus 1 is equals to minus 1 square minus 1. So minus 1 square is what? Plus 1 minus 1 is equals to 0, right? So in the both case we get the 0. So P of 1 and P of minus 1 is 0. Therefore both are the 0 of the given polynomial. It is simple. If it is equals to 0, then it is a 0 of the given polynomial, and if it is not equals to 0, it is not going to be the 0 of the given polynomial. Alright, now let's move ahead with the another sum, and we need to find out the value of P of whether the given this value are the 0 of this given polynomial or not. So here, first of all, we need to find out p of minus 1 is equals to, right, here I can solve. First of all, I just open up this bracket, but without open up the bracket, if I want to find out, it is also be fine. Minus 1 plus 1 minus 1 minus 2. Minus 1 plus 1 is what? 0. 0 you can multiply with anything, it is going to be the 0 only. So p of minus 1 is 0. Instead you put here, also you will find out the value 0. Now 2. Now 2 plus 1. Wherever you find out the x, you need to put the 2. So 2 minus 2. So here it is 3 and here it is going to be the 0. You can multiply anything with the 0, you will get 0. So here it is 0. So here, since p minus 1 p2 is 0, therefore x is equals to minus 1 and 2 are the 0 of the given polynomial. Okay. Now another sum, and that is p of x is equals to x square, where x is equals to 0. That means p of 0 is equals to 0 square is equals to 0. If it is 0, then therefore x is equals to 0 of the given polynomial. Okay. So in the same manner you need to do the another sums, but the one thing that you need to keep in mind is, if it is equals to 0, if you find out is equals to 0, then yes, and if it is not equals to 0, then you can say no. That we already seen the theory part. Okay. Now here these two values, we need to check that out. 3x square minus 1. So x is equals to minus 1 upon root 3. So instead of x, what we need to put is minus 1 upon root 3. So 3 into, see here I done this step, minus 1 upon square root of 3 whole square minus 1. So 3 into, the square becomes plus, so 1 upon 3 minus 1, because square of root 3 is what? 3. 3 cut 1 minus 1 is equals to 0. Okay. So it is 0. Now let's talk about the 2 upon root 3. So p of 2 upon square root of 3 is equals to 3 into 2 upon square root of 3 whole square minus 1. So 3 into 2 square 4 root 3 square 3 minus 1 is equals to 3 cut. Answer is 4 minus 1 is equals to 3 is not equals to 0. Is not equals to 0. So 3 is not equals to 0. So since p of minus 1 upon root 3 is 0 and p of 2 upon root 3 is not equals to 0, therefore x is equals to 1 upon root 3 is 0 of the given polynomial. This is the 0 of the given polynomial, but x is equals to 2 upon root 3 is not the 0 of the given polynomial. Right? If it is equals to 0, then it is 0, and if it is not equals to 0, then it is not the 0. Now x is equals to 1 upon 2. So p of, instead of x, what I have to put is 1 upon 2 is equals to 2 into 1 upon 2 plus 1 is equals to 2 and 2 cut. So 1 plus 1 is equals to 2. So 2 is not equals to 0. Now since p 1 upon 2 is 0, p 1 upon 2 is 0, therefore x is equals to 1 upon 2 is the 0 of the given polynomial. Now here, find out the 0 of the polynomial. Find out the 0 of the polynomial in each of the following cases. Okay. So p of x is equals to x plus 5. So p of x is equals to x plus 5. Now whenever you have to find out the 0, you need to compare it with the 0 is equals to x plus 5. If 5 comes onto the another side, it becomes minus 5 is equals to x. So x is equals to minus 5 is the 0 of the given polynomial. Now here p of x is equals to x minus 5. What you have to do is, instead of p of x, you need to find out the 0, write down the 0, minus 5 comes onto the another side, it becomes plus. So x is equals to 5 is the 0 of the given polynomial. Okay, 5 is the 0 of the given polynomial. Now here p of x is equals to 2x plus 5. So 0 is equals to 2x plus 5. Now 5 goes on to the another side, it becomes minus 5 is equals to 2x. Now 2 from the numerator comes into the denominator, so minus 5 by 2 is equals to x. So x is equals to minus 5 by 2 is the 0 of the given polynomial. Now x is equals to p of x is equals to 3x minus 2. So 0 is equals to 3x minus 2. Now minus 2 comes onto this side, it becomes plus is equals to 3x. 3 from the numerator comes into the denominator. So 2 divided by 3 is equals to x. So x is equals to 2 divided by 3. So therefore this is the 0 of the given polynomial. Now p of x is equals to 0, 3x is equals to 0, x is equals to 0, because if you write down 0 upon 3 is nothing but the 0 only. So x is equals to 0 is the 0 of the given polynomial. Alright, it is that simple sums. Right, this is the last sum for today, and that is p of x is equals to ax. P of x is equals to ax, and where a is not equals to 0. Here you are given the condition that a is not equals to 0. Why this condition is given? Because if it is equals to 0, then the whole term is become 0. So there is no need to find out the 0, right? So if you can write down the constant here with the anything, you need to specify it is not equals to 0. So here p of x is equals to ax. So here you have to write down the 0 is equals to ax. So x is equals to 0 upon 0. One more thing, 0 upon 0, it is going to be the infinite term. 0 upon 0 is going to be the infinite term. Therefore also you can write down a is not equals to 0. So here if a is 0, then this term is going to be the infinite. So that is why we need to say that a is not equals to 0. So p of x is equals to ax, 0 is equals to ax, x is equals to 0 upon a, x is equals to 0 upon a, therefore x is equals to 0. So x is equals to 0 is the 0 of the given polynomial. Now similarly, we need to find out for this, what? That p of x is equals to cx plus d. So therefore 0 is equals to cx plus d. Now d comes onto the another side. Here one thing you need to keep in mind, here p of x, that means x is the variable, and d and c are the constant. C is the coefficient and d is the constant. So c is not equals to 0 when c and d are the real numbers. Okay, so here if it is x, then x is the variable and other two are the constant term. So therefore p of x is equals to cx plus d, and therefore p of x is equals to 0 is equals to cx plus d. If d comes onto the another side, it becomes minus d is equals to cx, and therefore c comes into the denominator, so minus d upon c. So minus d upon c is the 0 of the given polynomial.